Great talk. Okay, any questions?
Hi, you mentioned about redshift estimation from supernovae, and you also mentioned about quite a lot of these galaxies will have photometric redshifts available for the hosts. I'm curious, is there any way to combine the inference of the supernova redshifts and the host galaxy redshifts into a single framework, as opposed to getting a redshift for supernova and a photometric redshift for the galaxy separately?
Yeah, for sure. That's actually in the paper, this paper that I'm referencing. We sort of like combine them using a Bayesian approach. So like usually with LC-FIP, this green line LC-FIP plus Z, they would take the host galaxy like photometric or spectroscopic redshift as a prior. This is displayed without like these results are without any prior, but if you do combine it sort of in a Bayesian way with the host galaxy redshift as a prior, the LC-FIP plus Z estimates improve, but ours improve as well for like, serious outliers. But I think for the most part, our PDFs are much more constrained than those of the photometric host redshifts. So when it's sort of within the right range, it doesn't really help much. But definitely a good question.
Yeah, then great results. Is the green one, is that using the host photometry and you're using the supernova photometry? Is that the difference? Or why is this so much better?
So the LC-FIP plus Z, the issue with LC-FIP plus Z in the way that I'm displaying it now is that it's like this like MCMC approach, and I'm not using any host galaxy. So there's like no prior on, like no host related prior on the MCMC, so it doesn't converge very well unless you give it some kind of like constrained space to walk in. Yeah, but if you do give it, a photometric redshift prior, it does do better, but it doesn't do as well as we do.
Oh, question.
Yes, thank you. How many classes did you train Scone with, and did you perform any data quality cuts by which, I mean, maybe do you have a requirement for minimum number of measurements within the events or a minimum baseline?
Yeah, so for the main SCODE results, we definitely did do some like cosmology grade cuts. But for the early thing, like the early time detection, we didn't really. I guess the whole point was to figure out how little data we could have and still do well. So we didn't do anything. But for Scone, we did six different supernova types. But for the Connect Later work, that's like the true plastic data set, which is 14 transient and variable types, not limited to supernovae.
Okay, let's thank Helen again.